So this final problem is a radians problem. We need to do the problem in radians and then convert to degrees. This is common when trying to calculate gear ratios and gear rotations. When we have a gear train, we want to, based off the movement or the rotation of the driving gear, figure out the movement rotation of the driven gear. For example, if the driving gear is going at a particular speed, we want to be able to calculate the speed of the driven gear. So radians allow us to do that because they relate an orientation, an angular orientation, to circles. So with this problem, the algebra is pretty much all walked out for us. We see that arc length is equal to the radius of the gear times the angle in radians. We see that the arc length of both gears has to be equal. It has to be equal for both gears. So we can use that relationship to solve for the angular movement of the large gear based off the angular movement of the small gear and the ratio of their radii. I know that probably all this yellow highlighter is not really helping out, but we're going to use the angular movement of the small gear in conjunction with the ratio of the radii between the small and large gear. So here we really just have to plug in numbers. We really just have to plug in numbers. So first let's plug in the radii. So we have 4 inches times something divided by 7 inches. So the movement of the small gear is 1 revolution, which that means that's 360 degrees. And as we saw above, 360 degrees is equal to 2 pi radians. So let's put in 2 pi here. So if we were to solve for this, we would get 8 pi divided by 7. So we can take this radian measurement and multiply it by 360 degrees over 2 pi. And here we would get, let's see, 8 and 2 would go to 4. The pi would cancel out, divided by 7. This would equal 360 divided by 4, or 360 times 4, that's 1040 divided by 7. Let's see what that is. So 1040 divided by 7 equals 205.7. We round to the nearest degree. We get 206 degrees. So for every full rotation that the small gear goes, the large gear goes 206 degrees.